طيب بسم الله الرحمن الرحيم. يعني this lecture is a quick review of structural systems, what you need to show in your project. That in the next stage we will focus on the technical aspects, structural systems, MAP, the building envelope, materials, sustainability, and so forth. طبعا يعني we will briefly go over the basics of structural systems. We always have a structural system in our design for any type of building, big or small. And the structure is the main element that creates the form. You cannot create a form without a skeleton or a structure. It's like the human being. You have to have a skeleton to create a form. Forms cannot be created without a support to hold them in their place and location. We always have structural system with stones, with brick, with ice, with wood, with different materials depending on what is available in your geography or location. طبعا structural systems, they started to develop in the modern architecture after the use of concrete. So that's made a big revolution on how structural systems are used. So we mainly use reinforced concrete, steel, glass, aluminum, these types of materials that allow us to have higher structures and larger spans than the wood and stone and simple materials of the past. We started to have also new building types that did not exist before, like terminals, like airports, like factories, stadiums. All these are new building types that required new thinking and new materials. The structural system has to adapt or has to be selected to suit the function and enforce the architectural design that you have. طبعا we have several structural systems and they all are important for the architects as much as they are for the engineer. And today, in our today's engineering, they have the capabilities, the materials, the designs that can solve any big architectural problem. Well, we are not afraid anymore of the spans or the distances or dimensions. Engineering has evolved so it can really support any difficult or complex structural system that we need. The only thing that we all work with is gravity. This is what we are designing to resist, because any object tends to fall down to the ground because of gravity, and this gravity is translated into force, and the structural design deals with these different forces to reach an equilibrium stage. So there is nothing is affecting the other in a problematic way. So we have structure and we have construction. Structure is the skeleton of the building. Building construction, we have structure of the building and we have building construction. Structure, this is the skeleton that keeps the building hold it in its place. Building construction starts to look at the materials, the walls, the ceilings, and so forth. طبعا they complement each other but we have to start with the structural system to keep the building in place. And the architect's responsibilities in the area of structural systems is to apply general structural principles for the building, apply the codes and regulations. There are codes and regulations for structural elements and materials and compositions, and the architect must make sure that the contractor is following them. Otherwise, they will all be penalized. The architect, the structural engineer, the contractor, the owner, if they don't follow this. The architect also needs to understand the materials and technologies, the latest updated materials and technology, and apply that in the design decisions. Also, with the structure, we come with the environmental issues. Depending on the environment, hot, cold, snow, rain, we need to adapt the structural system or select the appropriate structural system for these areas. Okay, what if the architect does not recognize the structural systems? We might have failures in the building because the structure is not designed properly. And also, when you are modifying an existing building, you have to be very careful not to change any structural element. So that's why you need to understand the structure. You are not required to design the structural system. You are required to understand how it works, what is needed, so that you can create it or you can adapt it. Most of you heard about 2 or 3 years ago, an apartment building collapsed in Heliopolis because the contractor was giving orders to the workers to remove all the walls and columns from the space. So they removed everything, the whole building collapsed. Because they didn't know what's the difference between a load-bearing element and a non-load-bearing element. So it was a big disaster. The basics of structure, you might have learned in your structure courses that we have to think about 2 issues for the architectonics of the building. The strength of the structure and the stability, how strong it is to withhold all the forces, and how stable it is to not to move in any direction. So the structure must be strong enough and stable. It can be strong, but it might not be stable. It can tilt or move or fall in a certain direction. So we have to be not only designing the strong material, but also the stable structure in its place. There are many different scales of structures. Depending on the size of the project, you might have a house, a hospital, a museum, an airport, a tower. All these different sizes, they require different considerations that you have to think about. Structural systems are like the skeleton of the human being. You cannot see it, but it's always there. This is what makes you move, or sit, stand, run. This is the structure that you have inside your body. Also, any building has a structure system. You might not be able to see it from the elevation outside, but it is always there. So you as an architect must have this analytical view of any building. What would be the structural system of this villa, of this building, of this terminal, of this airport? So wherever you go, you have to analyze the system and make sure that you understand its elements and how it works. We have three basic structural elements that we use in our design. We have the linear elements, the traditional columns and beams. These are the very old historical elements that we started to use. And then we started to use surfaces instead of elements. So use the walls and the ceilings and the roofs as elements of structure. So we don't use columns anymore. And sometimes we have the spatial structural system, which encloses the facade, the elevation, with the core of the building and the systems in one element. So in your design, you might not have columns and beams in the museum design. You might have spatial system, a shell that covers the whole space that you are designing for your project. You might go to the surface if you have linear elements and planar elements that you would like to design, so you can depend on the surfaces. Very rarely that you will depend on the linear in our case. Some projects might choose to do that if the design is suitable. So you have to think about the appropriate structural system. It's not any structure. It's not always columns and beams. It's not always surfaces. You have to think and select the appropriate structural system that supports your design concept. Otherwise, you can select a structural system that destroys the concept. Please close this window. It's very cold. طبعا in the linear system, we have the basic elements, the columns and beams and slabs. And this is the famous sketch by or illustration by Le Corbusier in his theory, 5 points of using of modern architecture, how to use concrete, reinforced concrete in design, and how did it change the way we think. Before reinforced concrete, we couldn't do these cylinders or columns with small sections. We had to do columns like in the ancient Egyptian temples, large columns, because stone is weak. So it has to be big. But reinforced concrete is strong. So we can reduce the size of the column and make it thin in the vertical direction. We can have slabs that cover large areas, and we can have an open plan. We can have the whole floor of this building as one space. We couldn't have that before. We had to have wall-bearing walls and small slabs. And the stairs, the freestanding stairs, it was not possible before. So there are, this is an important theory that guided architecture, modern architecture throughout its time. The surfaces, as you said, the most important illustration is Mies van der Rohe, the German pavilion in Barcelona. This was designed by Mies van der Rohe in the Barcelona exhibition. And it was also a big leap in the theory of the, design and structural systems. And after the exhibition, they demolished the whole. But after a while, architecture critics said this was a very significant building. How come you demolished it? So they rebuilt it again in the same place with the same design. So actually, when you go to Barcelona, this pavilion is not the original, but it is rebuilt because of it was significant. As for the spatial design, we have a famous building, the Opera Sydney, by Jordan Adzen. This is one of the important illustrations of how the building is one structure. You cannot see columns and beams. You cannot see walls and slabs. It's all one element. And this is useful for the types of buildings that require this type of space utilization. Natural materials, they have their strength and they have their properties that we can use in our design and think about. As I said, the human being has a skeleton that makes you stand up or sit down. Also, the building has the same thing. All natural elements that require structures, they have a certain structural system. The egg is a structural system. It can take forces. It can hold the creature inside until it matures. And the turtle has a shell that protects the creature inside. The seashells, all these are types of natural structures that we learn from. How does it work? How can we imitate it in our design? So when you look at nature, you might find certain structural systems that you can use in your design. We know all the forces. As I said, the forces are created by gravity. All the forces that we see around us are created because of the gravity. If you leave anything at a distance from the ground, it tends to fall down. What is making it fall down? It is pulled by the gravity of the earth towards the center. And this is what we are dealing with in structural systems. The gravity that tends to take the building down, and we are trying to make it stand up. So when you think about the structural system, you actually think about forces. And what is the source of these forces? Gravity. Where is it coming from? The mass, the weight. There is a weight that you want to put in a certain place. So this weight is pulled by the gravity and it creates a force. If it's a big element or heavy, it will be big force. If it's light, it will be a smaller force. So this is the whole concept of structural systems. So we have these forces of pushing and pulling. When I try to push something, this is a force. I am creating it. How can this be related to architecture? The wind. When you have wind, the wind tends to move the building horizontally, and it creates horizontal force. The earthquake. Earthquakes tend to move the building right and left and up and down. So we have to make sure that the forces are all accounted for and not going to affect the building negatively. And the forces can be transformed into horizontal and vertical forces. If they are coming into a certain direction, they are translated into horizontal and vertical forces. So I need less force to move the object horizontally than I need to move it on an angle, because the force is reduced. What will I need to move the object horizontally with a vertical force? Endless force. Cannot move it with a vertical force. It can be moved by an inclined force. I need to push more, or a perfectly horizontal force that moves it. So these forces analysis is important to understand, because when you design a system, the forces are not all vertical and horizontal. Most of them are not, but we need to transform them into horizontal and vertical to be able to design the structural system. Other forces that we also have with compression and tension is the bending. If the object is strong enough, but it cannot move, it breaks with a shear. Or if we rotate the object, if you rotate someone's hand like this is called a torsion that creates pain, exactly like in the structural element. So we have many forces, the forces that created by gravity due to the object weight, and we have loads created by wind, by earthquakes, by snow or rain. If there is too much rain on the roof, it creates load. If there is too much snow, it creates load on the roof. So all these types of forces are translated into very simple types: compression, tension, bending, torsion, and so forth. And they affect our structures, and this is what we have to deal with. Vertical due to gravity, horizontal or lateral due to wind or earthquakes, sliding due to overturning of the building, and so forth. The forces that we have inside the building are two kinds of forces, of loads created by these loads. We have the dead load. The dead load is the weight of the building elements itself: the walls, the floors, the ceiling, anything that doesn't move. The live load, anything that can move. If this table is a live load, you as human beings are a live load. Books, model, anything that moves is a live load. So we have two types of loads in our building: the dead load, the load of the building, and the live load, the load of anything movable in the structure. And we have to understand what kind of loads do we have, what type of materials, structural system that you are using, and what is the load that it creates. You also have a movable elements inside. These movable elements, you have to also understand what will be the use of this floor. Is it going to be a storage, a classroom, an exhibition? Each type has its own loads that we have to account for. So this understanding of the loads is important for the architect to understand how are the loads translated into forces, and what elements will we use to account for these forces. So as I said, the loads can be axial on the same line, or they can be inclined to each other. They are all at the end translated into horizontal and vertical loads. And they affect the building in different ways. Maybe they tend to take it down to the ground so that we have to have footings, or it can move it, it tends to move it in a different directions. As I said, the elements of the architecture is one significant element is the column, and the column is distorted when it really has big loads on it, what we call buckling. The column tends to change its shape and be deformed into a curved shape, and this is called buckling. And it depends on the size of the cross section of the column. Beams are also important part of the structure because they carry the horizontal load of the ceiling above. So they have to be designed properly, and the beam is actually a very interesting element because the column is carrying only vertical loads, cannot carry any horizontal or inclined loads. The beam carries horizontal loads, and this makes it deformed so that the upper part of the beam is in compression while the lower part is in tension, while the column is always in compression. So that's why you find the beam steel is different according to the load distribution and the bending moment diagram. The steel is placed where the beam tends to break. So they have to add this steel to it. Otherwise, it cracks. So if you see a crack at the lower of the beam, means that there isn't enough steel in there. So that's why we have to put the steel here so the beam can take the tension forces below. Also, the beam can take a shear failure if it's too fixed in one side. Now this you will see in your internship or construction supervision in your summer internship, inshallah. طبعا the process quickly we talk about, we start by digging the ground and put the columns footings. They have different shapes and sizes depending on the columns. If it's too many columns near each other and it's a high-rise building, we use the mat, which is a thick concrete mat of reinforced concrete that can hold the structure above if it's a high-rise building. This mat is fixed in the ground by piles. We inject piles in the ground so that the mat is fixed in the ground below. One important element in the design of your structural system is to consider the grid or the module. The grid that you use for the design. Any shape that you design has a grid and module that it follows. And this helps you to design the structural elements, the mechanical elements, the circulation. So the module helps all these at the same time. So if you have a module, you'll find the module serves all the horizontal elements, and it also provides the same support for the elevations and the vertical elements. So it's not only for the elements on the ground or the horizontal elements, it also supports the vertical elements. The grid also makes you design more typical elements, more equal types of columns, and you can estimate the sizes of the columns. The column in the middle carries 4 parts of the module. The one in the corner carries 1/4. So the column A will be larger. But as an architect, maybe you don't want it to be larger. If you leave it to the structural engineer, they will make it bigger than the ones on the elevation, and that will create problem for you. So you have to review with the structural engineer the sizes of the columns. Also, the columns, they get smaller as they go up because the lower levels, they carry more load. So they need bigger size. When you go up to the last 2 floors, the columns can be smaller. So you have to consider all these variables when you design the structural system. So the column gets bigger as you go down. You have to decide as an architect, do you want to use the smaller size and increase the steel, or use the larger size and take it all the way up and reduce the steel above? It's a combination between the steel and the concrete. So you need to think about. You can think about the structure as a panel beams that can cover larger spans with different shapes. You can think about mushroom columns. So the column does not carry beams. No, the column carries the slab directly. But as a mushroom, instead of putting the beams on the corners, no, I'll put the beam in the middle. And then it goes up and carries the mushrooms. I can use a space truss. I can use a shell structure. The whole volume is one shell. So you have to think about the system that you are using. We start with, is it a high-rise building or low-rise building, and so forth. Okay, before starting this part, I think the time is running out, so we will stop here and reopen the same link again. Okay?